In this video, we're going to start to look at probability and how to calculate probabilities. So, probability relates to the likelihood of an event occurring. And a couple of definitions here. An experiment is a repeatable process that gives rise to a number of outcomes. An event is a collection of one or more of these outcomes. So, for example, if we're rolling a dice, the outcomes are the possible things that can happen. So it can land on 1, 2, 3, 4, 5, and 6. An event is either one of those or a collection of those. So, for example, rolling an even number, that is an event because that consists of the outcomes 2, 4, and 6. A sample space is the set of all possible outcomes. So again, that's the 6 possible things that can happen when we're rolling our dice. Where outcomes are equally likely, the probability of an event is the number of outcomes in the event divided by the total number of possible outcomes. And we're going to see a couple of examples of that here. So, example number 1. 2 fair spinners each have 5 sectors numbered from 1 to 5. The 2 spinners are spun and the sum of the numbers indicated on each spinner is recorded. We're being asked to find the probability that that sum is exactly 6 and then that sum is more than 6. And the way we can do that is using something called a sample space diagram. So if we consider the possible outcomes for the first spinner, well, spinner number 1 has outcomes 1, 2, 3, 4, and 5. And equally, the second spinner can also land on 1, 2, 3, 4, or 5. So we're ending up with these outcomes for each spinner. Now, we were told in the question that we were finding the sum of these outcomes. So it's always important, just while we're finishing off our sample space diagram, always important that we're reading the question and making it clear to ourselves what we're being asked for. We're asked for the sum of the values from the 2 spinners. So all that means is I'm going to add together in my sample space diagram the values for spinner 1 and for spinner 2. So 1 and 1, that's going to give us 2. 1 and 2, that's going to give us 3, and so on. So we can just fill that out as we go along. So 4, 5, 6, 7, 8, 5, 6, 7, 8, 9, 6, 7, 8, 9, 10. And these values in here are our possible outcomes. So the first question there was asking us to find the probability that the sum is exactly 6. Well, 6 appears in our sample space diagram 1, 2, 3, 4, 5 times. So that's 5 out of, now since there were 5 possibilities for spinner 1 and 5 possibilities for spinner 2, in total we have 5 times 5, 25 possibilities. So our probability is 5 over 25, which I could simplify to be 1/5. Part B is asking us for the probability that that sum is more than 6. So to find the probability that the sum is more than 6, in our sample space diagram, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values which are more than 6, and that is out of 25. So 10 out of 25. Again, I can simplify that, and that becomes 2/5. Our next example on probability then. So we're told that the table shows the times taken in minutes for a group of students to complete a number puzzle. So we've got that there. So between 5 and 7 minutes, there were 6 students. Between 7 and 9 minutes, there were 13 students, and so on. We're told a student is chosen at random, and we're being asked to find the probability that the student completed the puzzle in, first of all, under 9 minutes, and secondly, over 10.5 minutes. So the first thing we're going to look at, to find the probability, we need to know the total. And the way I'm going to find that total, we are going to just add all the frequencies together, but I'm going to add a row in this table for cumulative frequency, just so we can keep a total as we go. So our frequency there is 6. 6 plus 13 is 19, plus 12 gives us 31, plus 5 is 36, and then plus 4, that is going to give us 40. So our probabilities are going to be out of 40. So our first question, we're being asked the probability that the student completed the puzzle in under 9 minutes. So if I look at my times here, 9 minutes is the upper boundary of this class here. So this 13 people plus this 6 people all must have completed the puzzle in under 9 minutes, or in other words, this cumulative frequency, 19. So I've got 6 plus 13 is equal to 19. And of course, if there's 19 people and there were 40 in total, that is going to be 19 over 40. So our answer there is just going to be 19 over 40. Now for part B, we are being asked to find the probability that the student chosen at random completed the puzzle in over 10.5 minutes. Now if we have a look at the boundaries here, 10.5 is going to lie somewhere in this group. So we're in the group between 9 and 11. Now we need to figure out where in this group 10.5 lies. So the first thing I can do, I can find out the width of that group. 11 subtract 9 is going to give me 2. So that 2 is the width of that group. And since that group starts from 9 and we're trying to find where 10.5 is, I can do 10.5 subtract 9, which gives us 1.5. So 10.5 is 1.5 above the lower boundary of that group. Or in other words, as a fraction, I can write that as 1.5 over 2. That's the position of 10.5 within that group. Now that group has a frequency of 12. So I've got 1.5 over 2, which we may spot simplifies to be 3 over 4, times 12, because that's going to be the frequency of that group, and that gives us 9. Now what that tells us is that from 9 up to 10.5 in that group, 3/4 of that group would represent 9 people. Or in other words, if I just go to the table up here, this 12, we could say that 9 of those people were below 10.5 and 3 of those people were above 10.5, because we've got 9 out of the 12 within that group. So then if I wanted to find those which were over 10.5 minutes, I've got the 3 from that group plus the 5 who were between 11 and 13 plus the 4 who were between 13 and 15. So 3 plus 5 is 8, plus 4 gives us 12. So in total we've got 12 people out of that total 40. So 12 over 40, and that is going to be our final answer. That's going to be our probability that a person chosen at random completed the puzzle in over 10.5 minutes. That's the end of this video. Thank you so much for watching. For more A-Level and GCSE maths content, like and subscribe to N Jackson Maths on YouTube.